All right, so this is simultaneous equations involving quadratics or some kind of x squared function. In this case, it's not actually a quadratic, it's a circle function. So what we have over here for the first graph, we have a circle, which is x squared plus y squared equals 9, and it has a radius of 3 around center 0, 0. So this is actually what that looks like, which is there. And from there, we can see that that number over there is 3. That one there is 3, negative 3 there, negative 3 there. And that would be this equation number 1. And then I have the straight line, which is y equals, and I can rewrite this. Remember, I can write this as y equals to 2x plus 1, such that that, remember, is my y-intercept, and that over there is my gradient. All right, so y-intercept being 1, so that's 2, 3, so 2 would be over there, 1 would be over here. It has to go through 1, it has a gradient of 2. So the line would more or less look like this, going through the number 1. So I have a gradient of 2, so probably a little bit more steeper than that. And it will end up intersecting the circle at 2 points, over here and over here. Let's say we call this point A and we call this point B. And that's what we want to find. We want to find those two coordinates. We want to solve for x and y in this question. The first thing I'm going to do is substitute equation number 2 into equation number 1 for y. Because I can see y is equal to 2x plus 1. So I can replace y in the first equation with that. Being 2x plus 1, it'll become 2x plus 1 squared. And I have x squared plus that equals 9. As you can see, y is now no more in the first equation. We only have x's. It gives us an opportunity to solve for x. So I'm going to square this bracket out now. I can do it quickly, or I can write it out twice and use FOIL. So first, outer, inner, last multiplication, right? X squared plus 2x times 2x gets me 4x squared. 2x times 1 gets me 2x. 1 times 2x gets me 2x over there. 1 times 1 would be 1 equals to 9. X squared plus 4x is 5x squared. And then 2x plus 2x would get me 4x. And 9 moved over becomes minus 9, and 1 minus 9 becomes negative 8, minus 8. So I've got x squared plus 4x squared, which is 5x squared, just checking. 2x plus 2x, which is 4x, and 1 minus 9, which is negative 8. And now I've got this function which maybe I'm not sure how to factorize, or maybe it doesn't factorize. So I would use the quadratic formula, a equals 5, b equals 4, and c equals negative 8, and substitute it into the formula minus b plus minus the square root of b squared minus 4ac over 2a. All right, so from here, we continue and we substitute it in carefully. So minus 4 plus minus the square root of b squared, which is 4 squared, minus 4 times a times c, which is 5, times negative 8, divided by 2 times a, which is 5. So that becomes minus 4 plus minus the square root. This is 16. These two signs become plus. 4 times 5 is 20. 20 times 8 is 160. So yeah, 160 plus 16 is 176 over 2 times 5, which is 10. That gets me two solutions for x. X can equal negative 4 plus root 176 over 10, or x equals to minus 4 minus root 176 over 10. I'll put that on a calculator. So after substituting it into the formula, up into the calculator, I get those two x values, and I'm now substituting each of those into the formula. Now the best formula to use would be this one over here to get the y value, because it already has y as the subject. So if y is equal to 2x plus 1, then I can get y equals to 2 times 0.92665 plus 1. And I can also get y equals to 2 times negative 1.72665 plus 1. All right, so we end up calculating our respective y values after we substitute it in. Okay, so we get our x values, get our respective y values, and here we're just double checking if it's correct. Have we solved for x and y? Yes, we have solved for x and y.